Hi everyone, welcome to another video. This video is a continuation of the object-oriented programming video that you have seen in the last one. We have talked about the basic definition of class, objects, methods, and all of these things, attributes, features. And today we are going to talk about four more things: encapsulation, abstraction, polymorphism, and inheritance. These four are the core concepts of object oriented programming that we'll look into. We'll look into practical example, we'll look into the use case and everything. So let's get started. So let's get started with the definitions. I am not going to go with the formal definitions, rather I will give you a example scenario that you can relate with in your life and it would be easier for you to understand. When I talk about abstraction, think of that as like a TV remote. Okay. So when you are pressing the remote button towards your TV to change the channel, to increase or decrease the volume, what you know that if you press that plus button, the volume will get increased. If you press the channel change button, the channel will change, right? But you do not need to know the internal way the remote is talking to the TV, right? So this particular process of keeping things where a user can achieve the functionality of the given class, okay, in a object oriented programming without knowing how internally they are linking with each other is called abstraction. Okay, now let's come to encapsulation. What is encapsulation? Encapsulation means protecting your data. Okay, now when I say protecting my data, what do I mean by this? Let's say you have a bank account, right? You would not want anyone to go there and change your bank balance, right? Withdraw money or deposit money. I mean, obviously no one else is going to deposit, they are going to withdraw. But anyways, jokes apart, so that is the thing, like you need yourself to go in there to deposit money or withdraw money so that the bank balance can get changed, right? In Python also, the functions that you are creating, they are holding some amount of data, okay, and they have different methods. Any other class or any other method should not be able to get inside of that and make necessary changes until and unless they are specifically instructed or authorized to. Okay, so we are capsuling a method. Understand the word capsule. We are capsuling a method inside of that to protect the data. Okay, that's why this is called encapsulation. Okay, now let's talk about polymorphism. What is polymorphism? Polymorphism is many forms. This simply means that in terms of Python OOP, you should be able to use the same method name across different classes. A real life case scenario would be if I talk about the banking system, right? So withdrawing money from the ATM is a method, right? But withdrawing money from the ATM cannot be held specific to a bank. That means it cannot happen that you are only withdrawing money from the Axis Bank ATM. That is applicable for State Bank ATM. That is applicable for Standard Chartered. That is applicable for ICICI and many other banks, right? So the withdrawing money or depositing money, these methods are not exclusive to a bank. Okay, it is present in many forms. That's what polymorphism is. Okay, now let's talk about inheritance. Inheritance is pretty straightforward. The name itself suggests you are inheriting the properties, the way child inherit the property of their father. Okay, the way father have inherited their property from the grandfather or grandmother. This is how the inheritance goes down the line. Same way in Python, when you define a class, you can define a child class to that. The child class can inherit the property of the parent class. Okay, and then you can also down the line create more grandchildren classes and all, right? So that's what inheritance is all about. I hope the concepts are clear to all of you that what these four things are doing. Now let's look into the code example of all of these things. Okay. Now we are inside our notebook and we will start to write some code. to understand how exactly these things work. The very first one that we are going to look into is abstraction. Okay, so how exactly do we call abstraction? Well, we have a module for this. I mean, I'm just importing this to showcase how the abstract method works, but absolutely every single method that you write, they follow the abstraction. Okay, so abstraction is basically a concept that object oriented programming follows. This library or the module is simply to showcase that how the workflow of abstract method works. Okay, so I'll simply execute this. It's executed. Now see what happens. I am taking up a class. Okay, let's say the class is, let's say, sound. Okay, let me put this up as capital, and I have imported ABC here. Okay, I will put this in here. I will mention abstract method here. I'll tell you what is the basic difference. Now if I write this, I am writing, let's say def sound. Okay, nothing fancy, just something to write it up about. I'm not even passing anything here. Okay, that's simply a class. Now see what happens. Generally, what do we see? If we assign a class, we are able to assign that to object, right? So let's say if I, let's say, create another class, let's say animal. Okay, and let's say we don't pass on anything to it, and we create cat. Now see, two are classes only. Sound is also a class, animal is also a class, right? What is the difference? Sound is basically a abstract class that is following the abstract method, right? So what is the code difference here? The moment I am going to try to assign some object to it, the difference will come into play. Okay, so let's say first this one, animal. Okay, so let's see if I try to assign this animal class to this cat. Okay, now let's say, let make me the function a little bit different. Meow. Okay, and let's say this is simply going to print a statement, cat sound. Nothing fancy. Okay, or let's say I'm going to do the same thing for this. Instead of writing pass, print sound. Okay, all right, now see what happens when I try to assign this object, like cat, to the animal class. I'm able to assign this. Okay, and now if I do this, I get this print statement, right? Fair enough, that's how it should work. But see what will happen if I try to do this. If I try to take this class sound to an object, so let's say I create an object called guitar and I try to assign this, I'll get an error. Cannot instantiate abstract class sound without implementation of abstract method sound. Okay, so it simply means you will not be able to directly assign this class to an object, since this is an abstract class. Remember what I said, that the inner working is not going to be visible to the external user. So this is something like this. You are directly not able to provide this to a object if it is a abstract class. Okay, now see what will happen. Now instead of assigning this like this, what I'll do, I'll create another code block. I'll create another class. Okay, so let's say I'll create another class called music, and inside of this I'm going to provide this sound class. Okay, and then what I'm going to do, I'm simply going to def method 1 or whatever is there, right? Does not matter. Done. Now see, if I go ahead and do this, it happened. Oh, sorry. I have to also provide the method, right? The method that is there, that is sound. I forgot to do that. Okay. So what is the method name? Sound. Okay. We have to provide this particular method, the one that you have written here inside of this. Okay. So that is sound. Okay. Now see, I have provided the same method and now it's working. Okay. Now if I go ahead and it is simply going to get executed without any error. But you see, it will only take the particular statement that I have given in this music method. In the abstract method, what have given, that is print sound, will stay hidden. Okay. So this is what abstract method is all about. Okay. That it is directly not going to show or let you assign to any object, but you need to take this inside another class to make it work. I hope it's clear, everyone. For encapsulation, let's go ahead and use the banking example that we have taken. Okay, so let's say I will assign a class called class bank account. Okay, I'll initiate the init method. Here is a balance. Now here comes the important part. Self dot what this initial to underscore mean. This means that this is a private variable. Okay, so whenever we have to declare a private variable, to underscore needs to be given in front of that. Okay, so that the example that I have stated, right, that everyone is not going to be able to update your balance, withdraw money from your account and all of those things, right? So that's why we are going to be using this private variable. Okay, now let's go ahead and create two functions. Let's say deposit amount it will take, and what I intend to do, I intend to add the amount every time the deposit function runs. So let's say you are depositing 100 bucks, it is going to add it into your balance, right? The way bank works, nothing fancy. And then there is a function called get balance. So what this will do, this will simply fetch your balance. Okay, so self, and I'll call the private variable. That's it. Okay, this is my class. Now let's go ahead and assign an object. Account equals to, it is the name bank, yeah, all small, bank account. Now let's say this is my initial balance. Okay, so I'll simply pass on an initial balance as 1000 rupees. That's it. Done. Now, if I go ahead and write account dot get balance, what will I get? I'll get 1000 because that's what that is added to me, right? Initially, when I have assigned the class to an object. But see, now where the dynamic thing of this starts taking place, I start depositing money. Okay, so account dot deposit, I add another 1500. Okay, done. Now if I run the code, I'll simply copy this. See, it's added with this 20, like 1500. Okay, same thing. Now let's say I did not mention. Okay, let's go ahead and let's make it even more dynamic. I mean, def, let's say withdrawal. Okay, self and amount. If I make, what do I have to ensure? This time it is going to, sorry, decrease the amount. Okay, done. Now if I go ahead and do this, account dot, what was the name? Withdrawal. Okay, let's say 250 rupees. Okay, done. Now if I try to get my balance, it should be how much? It should be, why 750? Oh, my bad. So see what happened. When I added this line of code, I again initiated my object this, right? So again the starting balance went to be 1000. That's why it subtracted 250 and it became 750. So let me run this entire thing once again so that you get an idea. So I'm running this for the first time. Now I have 1000 rupees as balance, right? I will add this, it will show 1000. I'll deposit 1500. It's added. Now if I check the balance, it's going to be 2050. Now in the withdrawal, now I'll run this. So it ensures that 250 rupees is deducted. Now if I run this, 2250 is going to come. Clear everyone? Any doubt? You can let me know in the comments. Alright, let's move to polymorphism. What is polymorphism? Polymorphism is many forms. Okay, so to show an example, let's say I create a class called animal1. Okay, and let's say I create a method called def sound once again. Okay, self, and let's say this is going to simply print a sound. Okay, sound one or whatever, does not matter. Okay, now see what I'll do. I will create another class animal2, but this time I will repeat the method name. Okay, so the method being present in multiple forms, it can exist. Okay, let's say I'm going to name it sound2. Now see, the method name remains the same, that is sound. Okay, and that is assigned to two different classes. Now if I go ahead and try to do this, let's say an, I'm assigning to animal1. Okay, then let's say an2, I'm assigning to animal2. Okay, fair enough, two different objects assigned to two different classes. But now see what I'll do. If I go ahead and do this an dot sound, it's going to give me sound 1. Okay, but if I straight away and go ahead and do this an2 dot sound, it is going to give me sound 2. So the same method name, it's just that it assigned to different classes, hence its functionality becomes different. This entire spectrum of scenario is called polymorphism, present in multiple forms. I hope it's clear, everyone. Okay, now let's get into the last topic of the session, inheritance. What is inheritance? Inheritance means transferring of property ownership from, in the real world, it's generation to generation. In here, in the world of programming language, it's from classes to classes. Okay, so how exactly this works? So let's say I create a class called grandfather. Okay, nothing fancy. I create a method called def, let's say, house. So grandfather have built a house. Okay, let's say print I own the house. Okay, that's it. Class grandfather and they own the house. Now let's say if I create an object, obviously the grandpa object, if I call with the function name, is going to give me the statement, right? Now let's say I create another class father, but this time what I'll do, in the parenthesis I will put up the grandfather name. Okay, def car self print I own the car. Okay, now if I create an object called dad and I assign this to them, dad dot car, it's going to give me the result. Now till now it's all fine. Where the change happens, since, understand this very carefully, since I have passed on this grandfather in the parenthesis of the father class, this father class is automatically inheriting property from the grandfather. So if I do this, dad dot house, I will get I own the house. Although in the father class, I have not assigned any of the object, right? I mean, any of the method, sorry, the house method. Okay, but still I am able to get this. Okay, now see, it happens one way. If I try to do this, if I try to, what is my object name? Grandpa, right? Yeah. If I try to do this, grandpa dot car, it will throw me an error. Why? Because the car object belongs to the father and the object from the father cannot be inherited from the grandfather class. It has to be a downstream thing. Okay. Now, clear everyone? Let me keep the error and tell me. Let me tell here that the inheritance does not work upwards unless assigned. What do I mean by assigned? That if you assign the method separately, then it's a separate thing, but otherwise it does not work. Okay. Yeah. So let's keep it like this. Now I'll create class child and they will inherit property from father. Okay, def iPhone. Okay, I own an iPhone. Okay, that's it. Now let's say um, I'll just assign the object like this, child. Okay, now see what will happen. Son would be able to get the house, the car, and of course his own method, that's the phone. Okay, so this is what the changes are. The son inheriting the father's property, father already inherited the grandfather's property, so the son is having every single thing. And upward below, the father or grandfather will not have this iPhone method in them. Father will only have the house inherited and car has their own method. Okay, so that's how the inheritance works. Clear everyone? Now a child can inherit property from multiple parents. So let's say if I assign class, let's say, okay, I have already assigned an object called dad na, so let's say class dad1, something like that. Okay, and let's say def okay, def, let's say bike. Okay, let's simply provide a statement bike, that's it. And class mom1, def jewelry. Okay, self print necklace. Okay, so dad one and mom one, two classes. Now let's say I class son one is going to inherit property from dad one and mom one. Okay, def, let's say cycle. Oh, I forgot to assign the self parameter here. Yeah, okay. Oh, sorry, my bad. I did. I thought I did not. I again did it on the class. My bad. Yeah, it's correct only. Okay. Now let's say I just provide a name. Let's say Rohit. Rohit is son one. Okay. Now Rohit shall have access to all of it. Bike. And also his own method. Okay. So what did you learn? That a child can inherit property from multiple parents. A child can inherit properties from multiple parents. Now one last argument. What is the argument? That the vice versa, multiple children can inherit property from a single parent. Okay, so let's say I take up a class as, let's say, dad 2 def multiple child item, whatever is there. I'm just providing any whatsoever function name. Okay, don't pay concentration on that. Multi-child. Okay, that's it. Now I will assign son to that takes the object from that to. Okay, let's not create anything. Class son3. This is also assigning, I mean inheriting from that to pass. Okay, so if I do this, assign Raj to son2, Parag to if I do this Raj dot multiple child item, I'll get the answer. Same way, sorry, if I do this for Parag, I'll get the same element. So clear everyone how inheritance is working both ways. Children can inherit property from the parent, from single parent. Multiple children can inherit, and from multiple parent, a single child can also inherit the property. Okay, clear everyone? All right. So this marks the end to the object-oriented programming. So this marks the end of our session with object-oriented programming. We have looked into all the key concepts that object-oriented programming has to offer. Now it's your turn to practice. You can find the notes in the first comment, and you have my social links into the description. So please feel free to follow me if you like my work. Thank you, and make sure to comment. Bye. I'll see you in the next video.